In today's video, we will discuss about passing file descriptors. The first point related to this concept, the ability to pass an open file descriptor between processes is powerful. It can lead to different ways of designing client-server applications, which means that here one process is opening passing a file descriptor, nothing but we know that what do you mean by file descriptor? The one file is opened. With respect to that one, there is a one unique ID has been maintained. So that is what we can call as a file descriptor here. So that file descriptor ID we are passing to the other process. Okay. So that can leads to the different ways for client server applications. Okay, the first point. Second, it allows one process to do everything that is required to open a file and just pass back to calling process a descriptor that can be used with all the IO functions. Means, as I told, assume that you have a client and we have a server 2 process. Here client is opening the file. Assume that. In that case, the server just open a file and just pass back a calling process descriptor. That is nothing but for server we are sending the descriptor, and later on the server can performing its input and output functions even though the client is already terminated here. Okay. The next point, when we pass a open file descriptor from one process to another, we want passing process and receiving process to also share the same file table entry here. So I will discuss shortly what is that concept here. That means exactly in the Unix concept we are using the vnode table, that is inode table, sorry. So I will show it here. So just you can go through this diagram here. Actually there is a two process tables. One is, this is the one process and this is the one process, then file table, then vnode table. This is a reference to one process, this is reference to another process, but they are sharing the common vnode table. Okay. Receiving process share the same file table entry, means it is providing the pointer to access a particular file here. What normally happens when descriptor is passed from one process to another process is that sending process, after passing the descriptor, then closes the descriptor. That's what, as I already told, the client is the one process, it is already sent the file descriptor, but it is closes that descriptor, but descriptor is still open by the receiving process. That is the reason we can call as a open here. That is the advantage of this mechanism here. Okay. This is what I already discussed about the diagrammatic representation of the passing file descriptors here. Okay, just we can go through that. Process table is nothing but how many files are opened by a particular process, it will be shown. And next file table, it will show the status flag and offset values and vnode pointer. Vnode is nothing but it is a virtual node that it can hold all the attributes of that particular file here. Okay, using that one we can perform the different operations. Next, passing file descriptors. We are using the different functions to perform the things. First one, send FD, that is send error. So we want to pass the descriptor to another process. It can call either send FD or send error. So if suppose it is successful, then the send FD function will be executed. If it is a failure, then send error will be executed here. With respect to that one, what is the failure condition? That is the error message will be generated here, and both is returning the 0 and 1 on error here. The send FD sends the descriptor file descriptor across the stream pipe. Okay, send FD sends the descriptor file descriptor across the stream pipe. Then send error sends the error message across the string byte followed by the status byte. The value of the status byte is usually in the range -1 to 255 here. Receive FD is called by the client to receive the descriptor. If suppose the send FD and send error are called by the server, then in the opposite case the receive FD is called by the client here. And return value of this function is file descriptor on successful condition and the negative value on the error condition. A process, a server that wants to pass a descriptor to another process calls either send FD or send error. As I already told, here the server wanted to communicate with a particular client. So in that case, the server is executing either send FD function or send error function. The process wanting to receive the descriptor, then in that case, assume that client is wanted to perform the receiving part here, then it will call the receive FD here. The send FD function sends the descriptors FD to send across using the stream pipe. Means already we know that stream pipe is a bidirectional mechanism we are using between the two processes here, our Unix domain socket here. And with respect to these three IDs, just we can find it here. FD is nothing but file descriptor. That is already file is what we opened here. Okay. And the second one is pipe FD is nothing but it is a file descriptor of the stream pipe here. Okay. Stream pipe FD here. Okay. Then last one, file descriptor, it is indicating whether is a read end or a write end here. Then we will use the term spipe to refer to bidirectional communication, that channel that could be implemented as either stream pipe or a Unix domain's stream socket here. The send error function sends the error message using FD followed by the status pipe. The value of status pipe in the range -1 to -255 actually it is. The clients call the receive FD to receive a descriptor. If all is okay, the sender is called send FD, then the non-negative descriptor is written as the value of the function. Otherwise, the value is written as the status that was sent by the send error here. Additionally, if an error message was sent by the server, the client user function is called to process the message. The first argument to user function is constant, that is a standard error file number, followed by the pointer to the error message and its length here. Next one, an open server version. Using the file descriptor passing, what we discussed, the passing file descriptors here. We now develop an open server, an executable program that is executed by a process to open one or more files here. Here, actually what happens, the server is opening all the files and will kept open whichever the client need to access that file, it can directly access here. But instead of the server sending the file block to the calling process, it sends back an open file descriptor instead. This lets the server work with any type of the file and not just regular files here. Means open server version mechanism is nothing but just we are opening all the files, which are the files required by a particular client, it can access. So what kind of the benefits we are getting with respect to this method or this mechanism, that the server can easily be contacted by any client, similar to the client calling a library function. Means directly a client can communicate with the server here. The second point, if we need to change the server, then only the one program is affected, remaining program will not be affected here. The third point, the server can be a set user ID program, providing it additional permission that the client does not have. Means we are assigning the access permission to the server, means it is the only, just like it act as a admin here. The other clients, what it is accessing, it could not have any private, just it wanted to access the information here. Next, the process creates the stream pipe, and by calling is having the one simple structure. Just we can find it what I am explaining here. Client sends the request across the stream pipe and server sends back a response across the pipe. So one thing we wanted to keep in mind, again in this concept also we are using the stream pipes between client and server. Here the client is sending this way, open path name and open code. Then based on this request, the server is sending back to a response. It can call either by send FD or send error function. Using that one, it will respond to the a particular client here. Then we are having the client server functions. As we know that the stream pipes are useful for IPC between the related processes such as the parent and child process. But when we are dealing with the unrelated process, a named stream pipe is required here. There is nothing but the processes exist in one system, the another processes exist in different system. So in that case, we are using the client server functions here. So here, server listen, usually this is executed by the server, means it is giving the indication that I am now ready to provide the any kind of the services whoever want they can access. So based on this message, by executing this function, now the client can communicate to the server here. So this function can return the 0 file descriptor value on successful condition, then minus negative value on the error condition here. Then server accept, once again this is a listen FD, just we can find it here. Whatever the return value we got it from the previous function here, the same thing we are accessing here. Okay, accessing here, and later on this function is also executed by the server. Once again it will returning the new file descriptor. If okay, then minus 1 negative value on the error conditions here. Now the client can communicate to the server by calling the one function client connection here. Then it is providing its name and its details by using this name function, but it is returning the file descriptor with respect to the client here. So this is the three functions we are using between client server connections here. But one thing we keep in mind here, it is kind of the socket mechanism we are using between the two processes here. Okay. Some more concept we'll discuss in the next video.